Here are some more examples on binomial distribution. One type of exercise I showed in last video, and now here there was find the probability. And here see the problem, the nature of the problem. Determine the binomial distribution which has mean 4 and variance 3. This is of course this is a mathematical exercise, but it carries the meaning that with the help of this type of information we can also determine the probabilistic population. How we can determine? Determination of binomial distribution means to have an expression like this: x follows binomial distribution NP, and to have this probability function px equal ncx p power x q power n minus x. How we can have these two information? To have these two information we need n. For that we need to know the values of n, p and q. How these values will come? These values will come from this relation. We know mean is NP, we know variance is NPQ, and in our problem the value of mean is given 4, the value of variance is given 3. It means NP is given 4 and NPQ is given 3. A simple algebraic calculation, NPQ divided by NP is 3 over 4. NP cancel, yani Q equal 3 by 4. Now we got Q. We need P because between P and Q this is the relation, P plus Q is equal to 1. So P will be 1 by 4. Now we got P. Now we need N. Because NP is 4, we calculated Q is 1 by 4. So this expression will give me N equal 4 multiply 4, 16. Now I can find the relation. Okay, binomial distribution is X follows B. In place of N I write 16, in place of P I write 4. And I can write Px now, and Cx, N is 16, I write 16 here, P power X, P is P power X, there is a mistake, P power X, sorry, this is X, 1 by 4 power X and 3 by 4 power 16 minus X, this result, okay. More exercise on binomial distribution. Determine binomial distribution if the mean is 5 and variance equal 8. These type of problems are more attractive problems for quiz. Determine binomial distribution if the mean equal 5 and variance equal 8. When you see this problem, don't start immediately the working. Check the information which you are given. Here the information are wrong. It cannot be determined. Why? Because we must have mean more than variance. Here mean is less than variance. Stop here. And in this case you will find the answer. You can have the choices, many choices, and one choice may be none, and one choice may be information is wrong. Informations are wrong and one choice is none. Don't tick none, because here information are wrong. If information are correct, we could be possible. It could be possible to get to the solution. Because informations are wrong, that is why the solution is not possible. That is why the answer is information is wrong. Okay. For Px is equal to 5Cx, 1 by 3 power x, 2 by 3 power 5 minus x. Yani n is 5 and P is 1 by 3 and Q is 2 by 3. Find the probability that x has value minus 2. Okay. This again, the question is wrong. This probability cannot be evaluated, as the range of x here will be x0, 1, 2, 3, 4, 5. X is not going to have a negative value. X is not going to have a value minus 2. So how we can calculate the probability? So this question is wrong. Okay. The answer is that this probability cannot be evaluated. Note, in general, in no case a binomial variable may take a negative value. It will always be a positive value. This note leads us for this decision. Problem 3. If an experiment is repeated 600 times, with probability of success P equals 0.5, find the probability of 10 successes. This problem clearly looks like n is given, P is given, and he is asking probability x equal 10. this problem looks like a binomial problem, but this problem does not belong to binomial distribution. Why? This problem looks like a binomial problem, but should not be dealt with. Why? As it breaks the two conditions for a random variable to be binomial variable. The first condition is n is very large here, n is 600. We need n 30 or less than 30, and probability of success and probability of failure are too much different. Probability of success is 0.05 and probability of failure will be 0.95. That they are, and the condition for binomial distribution is the probability of success and probability of failure must be of same order. Their values must not be too much different. The matrix is too much different, and the number of trials is also very large. This case does not belong to binomial distribution. It will be solved by some other distributions. Okay. Here I have written some exercise for you. If you understand this video, so it should be easy to you to calculate. It is known that 20% items are defective in a lot of a production house. What is the probability of having 3 defective items in a sample of 10 items from that lot? Here you will find the probability of success is 20%, any 20 over 100, and P equal 20 over 100, and this is 0.20. So obviously Q will be 0.80. But here you cannot say, the difference is also difference is here more, but we cannot say this problem cannot be dealt by binomial distribution, because this condition is favorable too much. Because of this condition, we will use binomial distribution. So we can see that from my last example and this example, what is the important condition? Important condition is the size. If size is finite, even if probability difference is more, we should go for binomial distribution. Okay. The MGF of the distribution is mxt 1 by 4 et plus 3 by 4 e power 5. Find its mean and variance. Okay. There are two methods. There can be two methods. One method is, as we studied binomial moment generating function. From moment generating function, we can find first moment, second moment, etc. The first moment we can find by differentiating moment generating function and putting t equals 0. This is first moment is directly mean, and second moment we can find by this rule. Variance is variance we can find by this rule, mu2 dash minus mu1 dash square, and mu2 dash we can find by differentiation of this rule, and differentiate second time. We can find mu2 dash, find mu2 dash and find mu1 dash, and use this rule to get the variance. Okay, this is one. Another simple situation is this, one of my students suggested before. Okay, here n is 5 and p is 1 by 4. The mean is np and variance is npq. We can find like this also. So you have two methods, this or this. Okay. Problem 3. Okay, if the probability mass function of a random variable x is this, find its mean and variance and MGF. Mean is NP, n is 20, p is 1, 3. Mean is NP, 20 multiply 1 by 3. Variance NPQ, n 20, p 1 by 3, q 2 by 3. MGF has this rule. To put this information in this format, you will find the MGF. Okay, try to do these problems. And next distribution we will take Poisson distribution. Okay. I will try to have 2 or 3 distributions from discrete and at least 2 distributions from normal, and that will be the last topic for our this syllabus or this semester, and inshallah khair, and the time whatever time we will have, we will do some more practices.